theory and stochastic processes. In this lecture, we talk about variable length coding techniques. Source coding is the process of converting the given log information into binary form. Source coding actually consists of a number of steps, that is sampling and quantization, and finally binary encoding. So source coding can be defined as the process of allocation of a group of bits called as codewords to a given quantized sample or symbol. These samples can be numericals, or sometimes they can be alphabets based on the message that is to be conveyed. Number of source coding techniques exist, like a fixed length coding. In fixed length coding, same number of bits are allocated to given samples, number of samples. Same number of bits means not the code words. For example, let me take few values. I have few levels 0.1, 0.5, 0.9, and 1.5. These are the amplitudes which need to be converted into binary form using source coding. So in fixed length coding, what we do, we allocate fixed set of symbols, either 0, 0, or 0, 1, etc., to each and every symbol or symbol. We have observed here, each and every group of bits consists of 2 bits only, 2 bits only, 2 bits only. It means the length of the code word is fixed. What is the meaning of code word? Code word is nothing but a group of bits allocated to each and every sample signal, are also called as a quantized sample. So in this context, the length is fixed here. That is why we call this as a fixed length coding technique. However, fixed length coding is not perfect in terms of coding efficiency. Whether it is required or not, we are allocating same number of bits to each and every quantized sample. Okay, remember that point. Fixed length coding suffers from the drawback of poor coding efficiency. What is fixed length coding? In fixed length coding, the length of the code words allocated are same in length, are fixed in length. What is the meaning of a code word? The group of bits allocated. This is a code word. This is a code word. This is a code word, and this is the code word. And what is the length of the code word? In this case, length of the code word is 2. So it is called as fixed length coding. What is the drawback? Coding efficiency is poor. That is why we mostly use variable length coding techniques. In variable length coding, the code words allocated in variable length coding, the code words allocated are going to be not having same length, but they are going to vary in length. The length of the each and every code word is different. Take the case of previous example, what you have considered 0.1, 0.5, 0.9, right? So 0.1, 0.5, 0.9, 1.5. In the case of variable encoding, this can be 0, this can be 1, this can be 1, 0, this can be 0, 0. So doubt may come immediately. What is the advantage of variable encoding? Of course, variable encoding reduces the number of bits required for transmitting a message on some levels. Okay, so variable encoding reduces the number of bits required for transmitting a message. That is the advantage. because the objective of the digital communication is to convey the information precisely. Unnecessarily, we should not use a large amount of data for conveying small information. So what is the objective? We want to reduce the number of bits. So which one is best? Variable length coding is best. What is variable length coding? Variable length coding is the process of allocating code words that vary in length to quantized samples. Okay, so what is the advantage? The advantage of variable length coding is in turn, it increases the coding efficiency. Okay. So whatever techniques they are going to be, variable length coding increases coding efficiency. In other way, it reduces the redundancy. Unnecessarily allocating more number of bits is not needed in variable coding. For example, say I say one word, I want to write Rama. So are we write the name Rama as like this? No, no. Unnecessarily, so many number of A's are not required. Simply that is sufficient. R-A-M-A Rama. This is sufficient. This is wrong. This is the essence of variable length coding. And what is the process involved in variable length coding? How we are going to allocate more number of bits or how we get less number of bits is in the following manner. So in variable length coding, the essence is like this. More probable symbols or sometimes we call samples from the quantizer. Symbols or samples are given less number of bits. Same time, less probable symbols. Same time, less probable symbols or samples given more number of bits. So what is the advantage of this one? The advantage of this approach is reduction in the number of bits required for transmission. Okay, so the most popularly known variable length coding techniques are two. Okay, many are there, but we are going to concentrate on two only types, two techniques. First one is Huffman coding. Okay, Huffman coding. And second one is Shannon, S-H-O-N-O-N, Shannon, S-H-A-N-O-N, Shannon, Fano coding. These two are the two different coding techniques. But objective is same. What is the objective? They are meant for increasing the coding efficiency, right? Either Huffman coding or Shannon Fano coding, they are meant for increasing the coding efficiency. So what is the process involved in Huffman coding? Let us illustrate with one small example here. Okay, so before we discuss about that, we have to know what actually the process of coding in Huffman. There are two approaches. Okay, but before you start the coding, two cases are going to be there. How they are coded. Case one. Probabilities are directly given. Okay, whose probabilities? The probabilities of symbols in the message. The probability of symbols in the message are given. This is case one. For given, are given. Case two is okay. Case two, the probabilities are not given. Message is given. Some message is given. What you want to convey, that message is given. So when message is given, we have to estimate the probabilities first before we go for coding. Estimate the probabilities first. then process is saved, right? So in this lecture, we are going to see both the cases. We concentrate on probabilities given in first example, second example, or third example. We take some message and do the complete process. Okay. So let us proceed with example one. Okay, see this. Very simple. Huffman coding technique is very simple. First one is see this. How many symbols are there? If you see the table given, it is consisting of 8 symbols: x1, x2, x3, x4, x5, x6, x7, x8. You may be worrying, sir, what is these symbols? These are the symbols used for conveying the message. These are the quantized amplitude levels of a voice signal. X1 can be 1 volt, X2 2 volts, X3 3.5 volts, X4 1.1 volt, etc., etc. Correspondingly, the probabilities will be given. What is the reason for going to probabilities? Because in variable length coding, we perform the coding based on the probabilities only. More probable symbol, less number of bits, less probable is given more number of bits. That is the logic for either Huffman coding or Shannon-Fano coding. Simply the procedure is different. That's it. So what we do now, first of all, we have to write the symbols given. Okay, we can form a table also, no issue. I'm going like this way. First one is symbol or sample. I just call it as xi. Okay, ith symbol. Then correspondingly, we write p of xi. So initially, how many symbols are there? X1, X2, X3, X4, X5, X6, X7, right? And finally, X8. These are the symbols. Then we have to write down what are their probabilities. 1 by 8, 1 by 8, 1 by 16. So let us write those probabilities here before we continue for coding, right? Okay. This Huffman coding technique is quite very easy technique. 1 by 8, 1 by 8, 1 by 16, 1 by 16, again 1 by 16, then 1 by 4, then 1 by 16. What these values are? These values are the probabilities. Finally, 1 by 4. Is it okay? So first of all, first column, write down the symbols. Second column, write down the symbol probabilities. P of x1, P of x2, P of x3, etc. Then stage 1 or step 1. What do we do? Arrange these probabilities in descending order. Okay, arrange the probabilities in descending order. So what is the order? Descending order. 1 by 4 is the highest. No, 1 by 4 highest. Then 1 by 8. How many 1 by 8s? 1 by 4, 1 by 4. Okay. 1 by 1, 2, 3, 4, 5, 6, 7, 8. 2 1 by 4s, 2 1 by 8s. Okay. 1 by 8. Then 1 by 16. 1 by 16, 1 by 16, 1 by 16. Now, step 2 or stage 2, number of stages you can call. Okay, what we have to do carefully. At step 1, what we have done, we have arranged the symbols in descending order. Then what we have to do, we have to add the last two probabilities, precautious, add last two probabilities, and again arrange them in descending order. So 1 by 4, 1 by 4, 1 by 8, 1 by 8, 1 by 16 plus 1 by 16 is again 1 by 8, right? So this is 1 by 16 and 1 by 16, right? Hope it is clear. This 1 by 8 is obtained by adding these two. Okay, then same process, step number 3. First one, no change. 1 by 4, 1 by 4, 1 by 8, 1 by 8, 1 by 8, and again these two are added. That is the process. At every stage, add the last two probabilities and again arrange them in descending order. Okay, stage 4, 1 by 4, 1 by 4. These two are added. So what happens? Again 1 by 4. 1 by 8 plus 1 by 8 is 2 by 8. 2 by 8 means 1 by 4. Okay, 1 by 4, 1 by 4. This is 1 by 8 and 1 by 8. Okay, stage 5. Again add these two. Okay, so 1 by 4, 1 by 4, 1 by 4, and here 1 by 4, right? Because of these two, we got this. So finally, what is remaining for the add these two? 1 by 4, 1 by 4 is 1 by 2, no? So 1 by 2, 1 by 4, 1 by 4, right? The last step in this process is add again the last. So you are left with 1 by 2, 1 by 2. Hope understood? Is the process okay? Just you take 1 second of time so that we can change that slide because okay. Right now we have to start the coding process. Right, this 1 by 2 is obtained by adding the last two symbols. Okay, how this is obtained? This 1 by 2 is obtained by adding these two. Now you have to start. Are the steps clear? Mention the symbols, write their probabilities, arrange them in descending order, and then add the last two probabilities and again arrange them in descending order. Till now, till only two probabilities are left. See this, only two are left. Now start coding. Allocate 0 and 1. Okay. And up to this steps are very easy. But now onwards, it will be a little confusing sometimes. This is 0. This is 1. Upper one, I have assigned 0. Lower one is 1. So this 1 corresponds to what? This 1 by 2. This 0 is the bit allocated to 1 by 2. This 1 by 2, how it came? This 1 by 2 came by adding these two. So for this child, you can call as a child, these two are the parents. So they will be 0, 0. Okay, they will become prefix and say 0. Remember this point very carefully, very carefully. Wherever there exists a parent node, correspondingly currently allocated, sorry, it is not 0, 0, 0, 1. It should be 1, 0, 1, 1, 0, 1, 1, because the value given here is 1. So correspondingly, you have to write as child has been given 1, no. So 1, 1, parent node 1, 0, 1. Is it okay? How it is given? This value is 1. So 1 is the prefix 0, 0, 0. Now, how this 1 by 4 came? This 1 by 4, 1 by 4, we have added, no? This is 1 by 2 is obtained by adding these two. So correspondingly, what next? This is 0. This is 0, 0, 0, 0, 1. This is the code given. Now, 1, 0, 1 by 4, 1 by 4. This is 1 by 4. So this 1 by 4 will be 1, 0, 1, 1. Because they are not derived from any other things they have got. Are they clear? 1 by 2 is obtained by adding 1 by 4, 1 by 4. So 0, 0, 0, 1, 1, 0, 1, 1. So see this first one first before we proceed. Okay, so this 10 is fixed, not came from anybody. 10 is fixed, 10 is fixed, and 10 is fixed because they are not derived from any other things. Similarly, this also 11 is fixed, 11 is fixed. Why fixed? As there are no parent nodes for them, they are assigned. Now see this process. This is 0, 0. So 0, 1. Okay, this is 0, 0, 0, 1. How this is obtained? This is 0, 0. Okay, and this 0, 1 obtained from this, no? So 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. The currently allocated code word becomes the prefix for the parent node, right? Okay. Then this is 1/8 corresponding to 0, 1, 0. This is 1/8 corresponding to 0, 0, 1. Is it clear? If there is a parent node or parent, current code word is the prefix. If there is no parent, current code word is final. Okay, then see 1/4. Current child parent is there. So 0, 0, 0, 0. This is 0. This is 1. Clear? Whenever there exists a parent, correspondingly, current code word is a prefix. Now let us continue. No parent. Okay. 0, 1, 0 fixed. No parent. 0, 1, 1 fixed. 0, 0, 0. This one. No parent till now. 0, 0, 0. See this. This is obtained from these two. No. So 0, 0, 1. 0, 0, 1. Parent. So prefix. 0, 0. Clear? We had precautious. Adding the probabilities is not at all a difficult task, but allocating the code words is little confusing sometimes. 0, 0, 1, 0. This is 0, 0, 1, 1, not 10. This is 0, 0, 1. And see, 1/8 is obtained by adding last two. No, again it becomes a prefix. 0, 0, 0, 0, 0, 0, 1. Clear? So in Huffman coding, the key point to remember is for any child which is derived from parents, the current word is becoming the prefix for the parent also. If there is no parent and only child is there, then the value assigned is fixed, like the first one. So this is the process of allocation of words. Now let us give actual values. 1/4 is 1/0. 1, 1, 0, 1/4 is 1, 1. Now this 1/8 is 0, 1, 0. This 1/8 is 0, 1, 1, 1. And this 1/16 is 0, 0, 1, 0. And this 1/16 is 0, 0, 1, 1. This is 0, 0, 0, 0. And this is 0, 0, 0. Clear? So once this process is completed, finally you have to mention what symbol is allocated, what code word in a separate table, right? So these are the probabilities and these are the corresponding code words. This is called as Huffman coding, which is an example for the variable length coding. And what we have considered here in this example, we have taken the symbol probabilities directly. So in a similar manner, let us go for one more example because so many examples to practice, that is the advantage. See this case. In this case, there are 7 symbols. Okay. In this example, second example, there are 7 symbols. Okay. So correspondingly, here also the probabilities are given. So let us proceed in the same manner. What we have to do? Write down the symbols, right? XY, write down the probabilities P of XI. How many symbols are there? 7, no? So X1, X2, X3, X4, X5, X6, X7, right? 7 symbols. What are the probabilities given X1? See carefully. X1 is a point not 5. X2 is a 0.15. X3 is a 0.2. X4 is a point not 5. X5 is a 0.15. X6 is a 0.3. X7 is 0.2. Sometimes you can verify whether the given problem is right or wrong. Sum of all probabilities must be equal to 1. I repeat, whether the problem is right or wrong, you can verify by adding all the probabilities. Sum of all probabilities is equal to 1. Okay, so symbols are mentioned, probabilities are written. Now, what do we have to do? Arrange the probabilities in descending order. So 0.3, then 0.2, then 0.15. Okay, 0.15, then 0.1, 0.05, 0.05. Is it clear? Arrange the symbols in descending order of probability. Step 1. Then step 2. What do we have to do? Add last two probabilities. So this is 0.3, no change, no change, no change, no change. And here also no change, and add 0.05 plus 0.05 is 0.1. Clear? Okay. Then again add last two. Now there is a change. 0.3, 0.2. This will be 0.2, no. So 0.2, okay. 0.15, 0.15. Okay, add. Now again add last two. Same process, very simple. Okay, 0.3, 0.3. Why? 0.15, 0.5, 0.3, no. Okay. 0.2, 0.2. Add last two. See how funny and how joyful it is. Add these two. So this will be giving you 0.4, 0.3, 0.3. Add last 0.6, 0.2. Right? Verify once. What are the steps? Arrange the symbols in descending order of probability. At every stage, add last two probabilities. Again, arrange in descending order. Till now, till only two probabilities are left. No, see this 0.4, 0.6. Once this is done, as in the case of a previous one, now also let us start coding. Right? Okay, how to code? We discussed already. No, allocate 0 to the upper symbol, upper probability, 1 to the lower one. But we have to follow same process. Somebody says, I will allocate bit 1 to the upper one, bit 0. Whatever strategy you follow, it must be from top to bottom. In between, if you change, it will be leading to coding errors. This point is to be remembered. So 0.6 is 0, 0.4 is 1. How 0.4? So this is okay. This 0.4. In this stage, there are no parents, right? But see this 0.6, it came by adding these two, no. So 0, 0 parents node, 0, right? Prefix. Current code word is the prefix of the previous code words, right? So this is 0.3, right? So directly you can say 0, 0. This is 0.3. You have given 0. However, this 0.4 is obtained by adding these two. So parent is there. So 1, 0, 1, 1. Wherever there exists a parent, current code word is a prefix. Remember. If the child is having no parent, whatever code word allocated is final. So 0.3. So this is, you can finalize this portion 0, 0 because no parent, no. So he is final. Okay. Okay. Then coming to 0.2. This 0.2 is 1, 0. Okay. No parent. No parent. Current code word is the prefix for the parent probabilities. Okay. Now this is 0.2, 1, 0. This is 0.2. This is 0.3, this 0.210, this 0.2 is 11, and 0.01, no, this 01 came from these two parents. So 0, 1, 1, 0, 1, 0, 0, 1, 1. Oh, clear? So this is a final 0, 1, 0, 0, 1, 1, right? And similarly, this becomes a 1, 1, 1, 1. This is 0, this is 1. As there is existing a parent node, correspondingly, the value 1, 1 is becoming a prefix. Let us finalize the remaining terms than this. This is 0, 1, 0. This is 0, 1, 1, right? And this is 1, 1, 0. What is this? 1, 1. Parents are there. Parents are there. So 1, 1, 1. This is 0. This is 1. Close. That's it. See how easy it was. At the end of the day, based on the availability of parent or not, if parent is there, current code word is the prefix. If there is no parent, it's over. Now we have to allocate as zero point 0.3. Where is 0 0.3? Here is 0 0.3. So 0, 0. 0 0.2. Where is 0 0.2? 1, 0. Here is 0 0.2. Because we have changed the order, no? Okay. 0.1. Where is 0.1? Here. So 1, 1, 0. Right? Then 0.05. Where is 0.05? Here. 1, 1, 0. This is 1.05. This is 1, 1, 1, 1. Another 0.15. Okay. What is left over? 0.15. This 0.15 is 0, 1, 0. This 0.15 is 0, 1. Okay. Actually, such type of ports are called as prefix ports. If you observe carefully, no code word is the prefix of another code word. Verify once. 1, 0. Does any code word is having 1, 0? No. 0, 0. Does any code word is having 0, 0? No. So what are prefix ports? In prefix ports, no code word is the prefix of another code word. Huffman coding is an example of prefix codes. What is the advantage of prefix codes? The advantage of prefix codes is they are uniquely decodable. Otherwise, confusion, no. As no code word is present in the another code word, you can easily decode them. Prefix codes are easily decodable, and Huffman coding is one example for the prefix codes. Okay, once this is completed, again you have to write the entire data in a table. Symbols, probabilities, allocated code words. Okay, so this is about one more variety. Okay, sorry, previous variety only. We have not given any message. So before we wind up this lecture, let us go with another example, with another variety. What is that variety? Till now, you have been given the probabilities. No. So let us go for a case. No probabilities are given. Construct. This is a construct Huffman code. Huffman code for the message. Construct Huffman code for the message. Classroom, 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 right? This is the message. In this example, the probabilities are not given. Huffman code is probability based algorithm, but here no probabilities are given. So what we have to begin? First of all, write down the alphabet. What are there? A, okay. Then we have C. Then what is the other one? L, okay. L, M, O, R, S. Okay, now there exists nearly 7 symbols. Classroom, C is there, L is there, A is there, S is there, R is there. This is called as source alphabet. Whatever symbols you are using for conveying the message, they are called as source alphabet. Okay, now what we have to do? We have to estimate probabilities. Okay, P of A. How to know? P of A equals to number of times A occurring by total number of characters. How many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9. So denominator is 9. 9 characters in the message and 1. So P of A is 1 by 9. Remaining things you can do parallelly, your own. P of C, not B, excuse me. P of C. How many C's are there? Only one. Again, 1 by C. 1 by 9. P of L. How many L's? Only one. Classroom. Only one. 1 by N. Then M. How many M's are there? Probability of M. How many? Only one. Again, 1 by 9. Then O. Classroom. 2. 2 by 9. Is it understood? Number of times a symbol is occurring divided by total number of symbols. P of O, then P of R, probability of R, classroom, only one time, 9, then P of S. How many times? S is 2 times, no class, 2 by 9. Clear? So this is the extra step in such problems. Okay. Whenever a message is given, estimate the symbol probabilities. How we estimate? Number of times that symbol is occurring divided by total number of characters, total number of symbols. Remaining process is same as we have done earlier. What is the process? Let's go ahead. Okay, so same as earlier. Xi symbol. This is P of Xi. What are the symbols? A, C, L, M, O. Okay. A, C, L, M, O, R. Yes. A, we know 1 by 9. C, 1 by 9. L, 1 by 9. M, 1 by 9. O, 2 by 9. R, 1 by 9. S, 2 by 9. Again, you can verify whether you are going in a right direction. Add all probabilities. 1 by 9 plus 1 by 9 plus 1 by 9 plus. If you add all probabilities, the sum must be 9. Remember. Whether the problem is done in a correct manner or not, you can verify by adding the probabilities. Okay, now remaining steps are same. Let us go. Step number 1, add last two probabilities. 1 by 9 plus 1 by 9. How much? 3 by 9. Okay. 3 by 9. Sorry, before we add, we have to arrange them in descending order, right? So step number 1, 2 by 9, 2 by 9, and 5 1 by 9. By 9, 1 by 9, 1 by 9. Add 2 by 9, 2 by 9, 2 by 9. How this came extra 2 by 9? Adding these two. Remaining things same. 1 by 9, 1 by 9, 1 by 9. Again, add last two. You won't change. 2 by 9, 2 by 9, 2 by 9. Again, add 2 by 9. Last one is not change. 1 by 9. Okay. So now 2 by 9 through 1 by 9 is 3 by 9. Descending order, no. 2 by 9, 2 by 9, 2 by 9. And 2 by 9. And last, what will come? 4 by 9, 3 by 9, 2 by 9. And last, close, 5 by 9, and 4 by 9. Clear? Okay. Clear. So we have added the problems. What next? Next step is simply coding. How to code? Start. Say upper one 0. You also start with me. Lower one is 1. These are the childs. This is child, parent no. So 1. This is child, parent is there. So prefix is there. 0 0 0 1. Again, right? How this 2 by 9 came from this? No. So parent is there. So this is 1 1 becomes a prefix 1 0 1 1 1 0 1 1. See this 2 by 9. This is no parent. So 0 1 no parent. 0 0 no parent here. 2 by 9 directly no parent. 2 by 9 2 by 9. Okay. 0 1 1 0 no parents. directly. This 3 by 9 came by adding. Two parents are there. Parents are still there. They're alive. Okay. Parents are alive. So they are there. Right. So 0, 1, final, no parent, no parent. Then how this came? This is 2 by 9. Okay. This is 1, 0, 0, 1. Okay. Wait. 2 by 9, 0, 1. Just let me just verify somewhere whether we have gone 2 by 9 is 0, 1. This 2 by 9 is 1, 0, 1, 1. Excuse me. Let me just take two small corrections here. This portion CC. This is 0, 1, 1, 0. Right? 0. This should be 1, 0. Yeah. 1, 0, 1. Sorry. 1, 0, 1, 1. So this is again 1, 0, 1. This is the problem of Huffman code. The branches are more, then it is going to be little confusion. 1, 0, 1. Okay. No parent. 0, 0 parents are there. 0, 0, 0, 0, 0, 0. Prefix. 0. Clear? So this is 0, 1. This is 1, 0. This is 1, 1. 0, 1, 1, 0. And this one will be 0, 0, 1. This will be 0, 0, 0. This will be 0, 0, 0, 1. And in this case, this is 1, 1, 1 parent. Finally, we have to rearrange 0, 1. Okay. One more. 1, 0. Okay. Remaining things will be no issue. We have arranged, 0, 0, 1, 0, 0, 0, and 0, 0, 0, 1, 1, 1, 0, 1. We have observed the length of the code word is not fixed. Sometimes 2, sometimes 3, sometimes 2. This is called as a variable length coding. Of course, I have to mention the steps here or stages with stage 1, stage 2. That is okay. Understood? Already understood. We did so many examples. S2, S3, S4, S5, S6. Finally, the essence behind Huffman coding is simply in this manner. Write down the symbols, mention the probabilities, arrange the symbols in descending order, add the last two probabilities, and again arrange them in descending order. Continue the process till only two probabilities are left. Then start coding. How we start coding? Upper probability 0, lower probability 1, or upper probability 1, lower probability 0. If the child node has a parent, this current code word is the prefix for the parent node. If there is no parent, whatever code word you have assigned is fixed. And once the problem is completed, we have to write down a table consisting of symbols, probabilities, and hope understood. Deep learning. We see in the next lecture with another variable length coding called as Shannon-Fano coding. Thank you all. But one point is very clear. Probability theory or these algorithms need a lot of practice. The practice is not done properly. Always it is confusion. We have to take variety of messages, estimate the probabilities, and do coding. So for you now also, once this lecture is heard by you, Do one example of your own. Thank you. Keep learning. Very good.